Hello community! Whenever you sit at your breakfast table and you read, hey, Meta's top scientist says OpenAI Sora is doomed to failure, you say, hey, interesting, what's going on between Meta and OpenAI? Let's have a look together. Now, if you don't know Sora, if you don't know Gemini Pro, if you don't know text-to-video AI, this is a simple video where I introduce it. And if you want to update Sora with the latest technological advancement, this is the video for you where I show you how you can do this. Yeah, in my video how to update the Sora algorithm, you remember? I went there to show you how you can update Sora, and then we went here. And I told you, hey, you have the classical Sora, or you improve here with a scalable interpolant transformer architecture to get a better performance. And we were talking about, where is it? About NVIDIA here with the diffusion vision transformer for the image generation. We were talking shortly about Meta's diffusion world model. And of course, I showed you here the next interesting step here, the ring transformer by Berkeley here with a near infinite context length of 1 to 10 million token, and the world model here from Berkeley. So we had an overview of Sora, Gemini Pro 1.5, and from Berkeley, the world model with almost unlimited ring attention. So coming back here to our epic battle between Meta and OpenAI, I have to tell you, there's a personal level and there's a business level. So the business level is really the fight for the future of all businesses. It is not just about AGI. This is really about the money. But there's also a personal level. And the personal level started here. Very early February 2024 at the World Government Summit, where all the leaders of the world came together to listen here to the scientist, Meta's AI scientist, about AI. What is the state of AI? What's going to happen in the near future? And here we have Meta's AI chief scientist, and it says, hey, if we have to predict multiple frames like in a video, we don't know how to do this. And all the leaders of the world said, beautiful, so no problem at all with AI here for some misinformation here on a video level. Beautiful. And then, just days later, Meta introduces here its latest research paper here on videos. Great. But the basic was clear, Meta does not know how to do it. Unfortunately, and I would call it here, it's a bad timing event. You know, February 15. OpenAI published here these beautiful Sora videos, and OpenAI showed that they know exactly how to do this, and they showed the world that it is possible, and it is already happening right now. Now, on a personal level, yeah, you can feel it, no? But never mind, 2 days later, here, I found here this tweet. It says, hey, there was a total misunderstanding of what I said. So beautiful. So we cleared this up. So all the world leaders that were there, this was just a total misunderstanding. And yeah, no problem. Because we as a research community, we understand it was a misunderstanding and it has nothing to do with the technological capabilities of Meta. And we are relieved to know this. Perfect. Meta is perfect. Great. However, there is a business case. And you know, that those two little fellow guys here, they invested in the last 4 years here, I would say rather this guy here, $50 billion in the metaverse idea. And now the company continues to invest in AI here through the Meta AI scientist. So this is a business case that you don't want to lose your investment of $50 billion. So what's happening right now? Interestingly, it is not only the big companies, but there are also some smaller companies that do some consulting, I think, what they are called. But I'm a scientist, I'm not familiar with these terms. And they tell all the other companies in the world, hey, do you want to win in the metaverse? We as a consultant, we know how to do. Here, I have an RE, a return of investment could be as high as 500% if you hire us consultants. And the conclusion, and beautiful, and this was 2023. So you see, the business idea, the investment and the business case is extreme. But coming back to science, you know, the metaverse, yeah, this was here one of the images, beautiful, this was the metaverse. And now we have OpenAI Sora. And if you watch closely, you will notice here a tiny little difference. Let's have a look together. So one company does know exactly how to do it, how to compose coherent video, coherent scenes, perfect video representations. Yes, of course, it uses a lot of compute power. But hey, between OpenAI, Microsoft, and Meta, I think these are secondary thoughts. So you see, we are here in a little bit of a field of tension between those two companies, because they are fighting not for science, they are fighting here for the business case. However, there is also a personal level, and I want to be clear with you. If I read, and this is today, February 23rd, 2024, if I read here, if you want to know what techniques will be reinvented in 5 years' time and will become insanely popular, then I tell you what you have to do. I'm not sure that I like this, and currently this person is shouting on all my channels that I have here, social channels. And this is something I might have a personal inclination of, not really liking this style, but we're here for the science. Beautiful. So here we have it, the publication by Meta. Interestingly, it is February 15 now here by Meta, so the exact day Sora came out. Yeah, interesting. Now, if you go there and you want to download it, there are a little bit tiny problems, but never mind. I will help you here with giving you here the link, also in a very helpful format as Meta tells us. Now, interestingly, this is not published where every other scientist on the planet publishes their work on Archive. If I put the exact same title here, this title into Archive, I get here, Visual Feature Learning with Deep Neural Networks, February 2019, or Revisiting Visual Representation Learning, January 2019. Okay, so no publication on Archive. You have to go to Meta, you have to accept the cookies, you have to accept everything that you are allowed to read the technical report. Okay. Now, a little bit of a hairy question for you. Imagine, in a theoretical scenario, for the last years, you could have spent each year up to $10 billion for research in AI. What would you have achieved? In which direction would you have advanced AI? Maybe also for the metaverse, if your direct boss is interested in the metaverse. And as a leader of a staff of 500 to 1,000 research scientists in AI research, what would you have achieved? So let's go to the GitHub Facebook research, and here we have it, the video joint embedding predictive architecture. Now, before we have a look at this, we look here at the citation because I want to be precise. So I want to cite this as an archive preprint without any source. So there's no link to any archive preprint. So hey, it is still missing, so I can't cite this work, which is really a pity because, sure, it's beautiful. So just have a look at the license file for the details about the license under which this code is made available. And you know, hey, Facebook is famous for being open source, so the license file will be okay, not directly here in MIT, okay, so yeah, consideration for the licensor, consideration for the public, exercising the license rights, the definition, adapted material, adapter's license, copyright and similar rights, effective technological method, expectation and limitations, artistic, yeah, license rights, non-commercial means non-primarily, share means, yeah, sui generis database rights. Oh, this is nice, beautiful. Every scientist will understand this immediately. A license granted, so we got a license granted to us. We have some exception and limitation. The term is here media and formats. Yeah, the downstream recipients. I think this is me as a user. Offer from the licensor, no downstream redaction, no endorsement. Other rights, amoral rights, patent and trademark rights are not licenses, so the extent possible. Oh, here we have the contribution, the conditions, the attribution, identification, Copyright, the notice. A notice that refers to the disclaimer of the warranties. Oh, warranties. Interesting. Who is responsible for this? Then the conditions here, the licensor, I request the licensor, okay. Sui generis database rights. Oh, now it gets interesting. This is where every coder is going to say, yes, this sounds good to me. You must comply with the condition, avoidance of doubt. Oh yeah, I would like to avoid any doubt here. Disclaimer of the warranties and a limitation of liability of this code. A term and termination. So, hey, there's no problem for us when we maybe will not use this code base. Okay, no problem at all. So, on we go. So, I don't want to get in any legal consideration if I'm allowed to show you code or whatever. I don't read this legal advice, and I give you here my personal impression after I have read the technical report. So Meta is focusing on unsupervised learning through a feature prediction from the videos. This is in contrast to what everybody else is doing, supervised learning methods, when the pre-training test describing the action of the video is available. So you have a text-to-video AI. And your supervised learning, of course, relies on large amount of label data, where each video must have a description or some label that identifies the action. And this can be time-consuming and costly. Meta decided to go to the non-time-consuming and to the cheaper way, and not do this, but just stay with the video itself. Okay. This unsupervised learning is now interesting because it will discover new pattern in the video, unexpected pattern, complete new trainable tokens that you have to find, and find new relationship in the video data. If you go with the supervised version, you would have here advantages. Because when you have here exact text describing what's happening in the video, you have a much better, a much more precise control over the learning process of your text-to-video AI, understanding what is happening and what you are training the system on. And you not have some unexpected pattern in the video sequence that are detected by your AI system, but there is no text allocated to this pattern recognition, so that you would know what patterns have been detected. You see where I'm going? Feature extraction. Here we have a beautiful ball. Bouncing ball. This is a feature I can extract. There is a blue ball. This is a feature, another feature I can extract. And a green ball, you get the idea. Now, panoptic image segmentation with vision transformer, for example, with a mask-to former, 11 months ago, I have here this mask-to former code example in PyTorch, and I went with you through the complete code example. So you have an image and you could identify each person, each handbag, each cardboard, each whatever handbag here with a certain precision. This was available a year ago. No problem. This is the code, open source. I have videos for the image technology 2023, 1 year old. I have here Vision Transformer 23 for cancer screening. And I have here the code for you if you want to find similar patterns here in a sequence of images for video. Beautiful. But let's focus here on the main features of Meta's methodology. So we have a feature prediction, unsupervised learning from video. And what you do is you predict the future segments of a sequence of images that constitute your video. How you do this? Meta has here the title of a joint embedding predictive architecture. Sounds fantastic, but it is simple what it does. It embeds here the video segments into a feature space. That's it. And in this feature space, you can have your relationship to predict what's going to happen. If you want to predict something, you need a start point A, and then you have the point B, the end point B, that you want to predict. So what they do? Simple, they encode it. We have two encoders for different segments of a video. So the past segments, this is the segment A, and the future segments, if you look at the future images in this video sequence, is then the future. So you have a state A and you have a state B. And what you do is You want to predict it. So you build here a neural network predictor, where you take a transformer with 12 blocks, an embedding dimension of 384. We have an input is a sequence of embeddings and mask tokens, and then you attempt to predict the embedding of the future segments that are here in state B. As easy as this, A, B, and you build a predictor that predicts B from the state A. You notice this is what we do every day. Yes, parts of the video are masked out and the model learns to predict the masked part based on the visible part. And you have noticed we have this here in the language modeling about 1.5 years ago, where we were operating also with masked language modeling. It is the same idea. The implementation is easy. We use vision transformers. You know them, vision transformer large, 16 or whatever. You go whatever you have compute infrastructure. And you have your classical pre-training of the model, and then a feature prediction for the fine-tuning task, for the downstream task that you are looking for. This is it. This was it. Great. Now for my green grasshoppers, for my younger community, hey, let's do it in a simple way. So here I have a simple example of feature extraction using here a method by Meta. 6 easy steps. You have an input. Okay, I have a ball bouncing on the ground, captured here from the side in a video. No labels, no description, just video data. Then, portions of the video are now masked out in a systematic way. So certain frame where the ball is at the peak of its bounce are masked, and then hiding the ball's position at these key moments. And you know what's gonna come. We have the feature prediction setting. We have a predictive task. And the model now, using its trained architecture, predicts the mask out feature, such as the position and the shape of the ball in the mask frames, based on the other visible segments of the video and the history of the video. The goal is to accurately predict where the ball will be, based on the learned, trained data. And through this predictive process, the system learns important features about the motion of objects, a ball bouncing up and down, the ball's trajectory, and how these features change its experience in different video frames. Think about it's night and you have a point source of light. Suddenly you have shadows and so much more. So it all depends on the learning data. Step 5. Model might learn features such as the downward movement when the ball comes down, or the upward trajectory when it bounces back in the air, or a deformation that happens to the shape of the ball when it touches the ground. Beautiful. It's not labeled, but the video understands this visual data and can find similar instances. And these learned features can then be used to identify or predict here similar motions of similar objects in new videos. However, be careful, you have enough training data, because you only do this here with a ball. This is perfect. But imagine if you take a piece of glass that is shaped as a ball, and you throw it on the floor and you expect that this glass ball bounces back, you will be amazed if you do not have enough training data. So you see immediately the limitation of this methodology. Yeah, forecasting or exactly predicting that with a 26.7 chance of, this is gonna happen. So let's have a look at this. It does predict here the future visual behavior in videos, but not in the direct sense of forecasting here specific events. It just focuses on predicting the features of unseen part in a video based on observed segments. You know this. The feature prediction, you have a motion pattern or object interaction, or how the scene changes over time based on the training data. It's only what was in the training data. So again, you extract features from the video frames, you embed them in the embedding space, you have your calculation in the embedding space. You do this with the vision transformer, who do the process of the video segments converted to embeddings, and now you have your embedded space. Now you hope that this system doesn't blow apart if you accelerate, if you give full power. So how we do the predictive learning process in detail? If you now compare now the embeddings of, for example, the mask segments with the predicted embeddings generated by the model, you see exactly how far apart they are. And you're not going to believe there's an optimization, and the optimization is, for example, you want to minimize the difference of those vectors in the embedded space, and you think, did I see some cosine similarities somewhere in the past when I did something with rec system, with vector store? Now, what a coincidence. Okay, again, short answer, why do we need here to embed objects? Why don't we go with your millions of pixels? No, we want to have here a reduction in the dimensionality, in the complexity of our mathematical operation. We do this, for example, with a topological reduction of, I don't know what, to a, let's say, 200, 300 dimensional mathematical space, where all the information that we are looking for are still there in this reduced mathematical space. And the model learns to recognize patterns and relationship in this reduced dimensionality space that we call an embedding space, and all the things happening over there. And of course, and here we have the business case of Meta shining through. If you want to do this for Instagram or for WhatsApp, it must be computational efficient, it must be cheap, it must be fast. It's not so, mathematically scientific. So yes, it is fast, beautiful. And therefore, Meta is focusing here on this methodology. What a coincidence, you might say. Again, predicting future evolution in the embedding space. Now you know that this is just a function that maps a sequence of embedding to future embeddings, and we have to optimize this function. And this is it to it. Beautiful. That's the end. Now you know exactly what Meta does here. It employs here a transformer block system to process the video data, learning spatial and temporal dynamics for the feature prediction of this video. That's it. Now, if you listen carefully, you noticed at the beginning I told you, we have from Meta also the diffusion world model. And we have here a diffusion probabilistic model to generate future trajectory based on current state and action. But this now is something completely different, because this model is now learned with reinforcement learning. Now, I have my personal ideas how you can combine this, but I think this is topic for another video. But just that you know, Meta currently is really proud here of the first one. And yeah, I have another hairy question for you now at the end of this video. You know that with Sora, with OpenAI, since we have a text-to-video AI system, you can write a prompt or you can speak something to create a synthetic video. With Meta's method, you remember we just have a standalone single component version of this system, because this system has no labels at all. You as a human cannot interact with this system, so you have to build a lot of additional modules. You have to integrate it in an ecosystem. And yeah, this ecosystem has not been published yet, but I have some ideas and let's see. But just for you to know, Meta, with its current official publication, they don't have labels. They just have a behavior of video sequences. So what does this mean for a business case? Now imagine you are sitting here with your beautiful new goggles by Apple and you want to go to your bank office. But of course, you want to go to your virtual bank office. So you put on your goggles, you visit your bank office for some transaction. You have a massive AI support when you enter here this virtual bank office. You have avatars and whatever. And you can talk here with this specialist here in the bank about if you need a credit or if you want to have some savings, what are the best way to do something. So this is an absolute personalized user experience. You have a beautiful interface where you see synthetic videos that directly interact to your needs, to what you say, to what you want. And if you can generate this in real time, my goodness, the whole service industry, you will dominate this with your technology if you license this out. This could be an explanation why Meta has such legal limitation on its current. And this is just one example, but another example. You visit an insurance office and you want to have some personal support for your personal questions. So you put on your goggles, you are suddenly in this beautiful room, somewhere on top of a skyscraper, and you have your avatar, your insurance avatar, and you say, you know, this is my question, and they perfectly individual statements for you. You have a perfect syntactic look around here. So whenever you can create from words virtual syntactic videos, this will be a business case for all sectors of industry, not just the service sector. Imagine you buy a new car and you put on your goggles and you have the perfect interface from your car dealership. And you can create these syntactic videos and you see exactly, you can sit down in your car, you can look around in your car, and this is an absolute immersive experience for you. My goodness, it is so interesting here. The new possibility and the business case, I suppose, are in the thousands of billions of US dollars. If you would be able to have this technology, and therefore, now at the end of this video, with a little smile, I think I understand why Meta's top AI scientist claims here, hey, OpenAI Sora, it is doomed to failure. I hope you enjoyed it. I see you in my next video.